Okay, there was a Leetcode jump game. You are given an integer array nums. You are initially positioned at array's first index. Each element in the array represents your maximum jump length at that position. Return true if you can reach the last index or false otherwise. See, basically, your amount arrays, right? 2, 3, 1, 1, 4. And I will say, yeah, do I see her say? Ujina say. That's here, do see her say, Ubi to me free kwakusi hanum sayana. Right? Number way, represented the number of jumps are ubi to my jumpy. Into basing way to my jumpy 2 jumps, right? Into 1, 2. Ukusi hanum ubi to my jump 1 pet. 1, right? Kusi hanum ubi to my jump 1 pet. Boom. Yes, ubi to me free about see hanum say. Right? Indeed, question is a mama different arrays determine say will to me every aquacusianoma. If you can't, then you just return false. Basically, you bet mark as ideally with mark as how you true. Right? Yes, that if you actually say with mark as how you true. Now for the wabahasi. You be starting now false, right? We are false. By name say how you true, so start free as how you true. Into say what start free and hanuma. Can you come here? Right? Into regional has here, wait to mark has here now. Yes, over 1 pair, over 1. So over 1 jump, so you can go here. So wait to mark hanuma, then hanum better than be true. So which now says well, can you go here? Because you say which now no ma be to my quarter that until all we need to know is can be to my be jump up is here no mana or 1. So yes, you can jump here. Until now hands will be you through. We be now has here. Wait to my quarter you have 3, right? Be to my cobacco. Cobacco and hands will be you through. Right? Which now says well 2. Only need 1 jump. It will be you through. It is all to me established say if you actually has say what start if you actually now go back which might be see and how be true there now for the na then you can return say a true, right? But say won't mean yes idea now you false. For example, we say 3, 2, 1, 0, 4. What start if you have bit my jump 3, right? 1, 2, 3. We see animal 0, 0 won't mean ko baby into waka. O jump 1 be see right? Bit my jump 2 from I say 1, 2. I see 0 won't mean ko baby right? Now you find say you starting fear chiri I say if you chiri now ba obejina here won't mean ko baby won't mean ko any won't mean ba which is into say no 0 will block you from going, right? Into and now so I force. Typically, this is it. In everyone say arrays so we array near index is 0, 1, 2, 3, 4, right? And see, say person say we big Marcus here a 1 plus the index no 1 plus index no be my 4, right? Because my 4 it means which my baby here say 1 plus index 3 will be my 4, 1 plus index 2 will be my baby here say ye 1 free way ye man my baby 2 even my baby here say, right? I say 0 into 2 can 1 with mama here 1 per cramponi here need I say. So this is the approach maybe you should solve this problem with programmatically. But you must start here for anywhere, but this one makes it easier for me to write it. So let's look at how we can write that in Python. First, let me get the length of nums, right? Yes, store by default no. Any BBR false, right? Insert it memoization as a default BBR to false here. Memo is equal to array of false times n, right? In the last one or any BBR find here as any default a true, right? As in the default you start here as in here set here no to be true from the beginning. And memo the last element is equal to true. For I in n minus 2 minus 1 minus 1. And this is how you represent looping from the back, right? N minus 2 because we're true to that anything here starting from say. Remember, index minus 1 is the length. The length minus 1 is the actual index, right? But we 1, 2, 3, 4, 5, 5. But index no, the last index is 4. The n minus 2 no, that is why we are doing that. They started from this one, and now we want to determine say from this one a bit too much jump here but has here, right? So if for j in range 1 to nums I plus 1. Now may nums I plus 1 because range, the last number is not included into nums I, but plus 1 will ensure that nums I is included, which means this one is included as well. Now we are about to determine say from how you bit my jump and this is how you will represent that. If I plus j is less than n, first of all you determine say I plus j the index, right? You start if you're an index near 3. Index 3, I is 3, right? The index of j is starting from 1 to 2 because nums I no here no is 1 plus 1 no remember be 2, right? Into from 1 to 2. I plus j is 1 plus 3. 1 plus 3 is less than n, which is the length of the array. It means it is within the index, right? And if memo I plus j, and this is checking say memo I plus j, which is 4, so memo at index 4, if it is true there, it means a bit too much jump here above the last one we say, right? Then we can see say memo at I is equal to true. So you settle that there, then we just need to break. Alright. Until we will repeat this same thing. Basically, this is the same thing we are going to do at this point. Basically, that's it. Into we are you just return the first index, be true, right? Say you true, then you have your answer. Return the first index of memo, right? You true and when your answer. basically that is how we solve our problem way, and this is how you write the algorithm to do that. So let's see if it works. Voila, that is it. There is a much more efficient way of solving it. Maybe I will do a video for that one too, but this is the dynamic process approach of solving it. And we complexity here, O of n, complexity no, time complexity is O of n squared, and then space complexity is O of n. Now we use a greedy approach ubenya O of n was for time and O of 1 for space. But I will do another video for greedy approach at some point in time. So if you don't say my with mutual comment in the comment section, and then I'll provide that solution as well. All right, thank you. Bye bye.